Hi, our name is Andy.
I'm Jasmine.
I'm Colin.
And I'm Russell.
And we tried to make 2 robots that would successfully map the 2nd floor of the EECS building. Enjoy the video!
Our project involved vectorized mapping with LiDAR, recognizing room signs with a Kinect, as well as path planning and autonomous navigation and object avoidance. And I'll talk about each of these components over the course of this video. All the computation for our project was performed on MacBooks on our MagicBots. Here you can see they're displaying the data, which we also streamed to a remote device. And we made particular use of the CPU as well as the GPU for serial and parallel algorithms in this project. Here you can see a visualization of the LiDAR data from the hallway outside the lab, with the key points that we've extracted marked in red. Our extraction algorithm focuses on corners, so it looks at the adjacent angles and straightness of nearby points to any given point, and is able to pick out the local maxima, which are the corners. We can also extract so-called occlusion points that are only straight on one side, but are a corner that we haven't gone around and is still blocking the background. Extracting these points is also important for the robot to be able to see things that it can't see just dead on. Here you can see mapping in action. We're able to control the robot remotely from this iPhone, and you can see the map that it's building on the screen. This map is made by taking the key points we extract using the previously described mechanism and matching them across frames using a ransack algorithm. We also connect the points with edges, where the edges represent 2 points that were observed in the same frame. Having this map allows us to correct the current position of the robot. The robot can also detect landmarks in its environment in the form of QR codes. Here we flip over to the camera screen and we can get a live view of what the Kinect is seeing. We can then get closer to this QR code where the local processing will analyze it, recognize it as a room sign in the environment, and add it as a landmark to the map. You can see as we get closer, eventually the placard will appear right there, that purple tag, and you can see it's placed it in the right spot based on the depth that we get back from the Kinect. Here's a closer shot of a similar map. Once a map has been made, you can tap on the phone to cause the robot to go into autonomous mode. This will cause it to generate a local occupancy grid of the surrounding 20-meter area, at which point it will run A* to find the shortest path to the place that you tapped. It'll do its best to avoid obstacles, as you can see here going around this chair. It can also navigate around people, although sometimes better than others. Thanks again to Professor Jenkins and the teaching staff for making this class super awesome. It was a great time.